A chip the size of a dinner plate just made a rack of NVIDIA's best GPUs look slow. Not by a hair, by more than double. And the reason why blows up everything you think you know about AI speed. Here's the secret the big chip makers won't say out loud. AI got slow, but not because it ran out of math. It ran out of memory speed. The chips are literally starving. Picture a genius locked in a room. He solves any problem in a blink, but the answers sit in a warehouse across town. So he spends all day running back and forth, grabbing one page at a time. That's a modern GPU. Tons of raw power, sitting idle, waiting on data. This is the memory wall. By the end, I'll show you the one company that smashed clean through it, and who that puts out of a job. Every word an AI writes, it rereads the entire model first. Billions of numbers. Every single token. That means hauling huge piles of data from memory to the cores, over and over. So speed isn't about how fast the chip thinks. It's about how fast you can feed it. The food pipe is called HBM, High Bandwidth Memory. It sits next to the chip and pumps data in. NVIDIA's B200, their flagship, moves about 8 terabytes a second. Sounds insane, right? It's not enough. The cores eat way faster than HBM can serve. So the most expensive silicon on Earth sits half asleep, tapping its fingers, waiting for lunch. The last gen H100 was even worse, stuck around 3.3 terabytes a second. That gap, between how fast a chip computes and how fast it gets fed, gets worse every year. Compute keeps doubling. Memory bandwidth crawls. Hold that thought, because there's a number coming that doesn't even look real. Now meet Cerebras. While everyone else sliced a silicon wafer into hundreds of tiny chips, Cerebras refused. They kept the whole wafer as one giant chip. They call it the WSE3, 4 trillion transistors, 900,000 cores, 46,000 square millimeters of silicon, one single piece. But here's the move that changes everything. They put the memory on the chip. 44 gigabytes of SRAM, sitting right next to the cores. No warehouse across town. The genius now has every page on his desk. And the bandwidth? NVIDIA's B200 does 8 terabytes a second. The Cerebras chip does 21,000 terabytes a second. Read that again. Not double, not 10 times, roughly 2,600 times more memory bandwidth. The memory wall didn't get climbed, it got deleted. And the results aren't theory. Running Llama 4, a 400 billion parameter model, Cerebras hit 2,500 tokens per second per user, more than twice NVIDIA's top Blackwell box on the same model. Stay with me, because there's a catch that decides whether this is the future or a dead end. The catch is size. 44 gigabytes is blazing fast, but it's tiny. The best models are far bigger. So you chain wafers together and split the model across them. It works, but it's pricey, and it burns power. OpenAI just signed a $20 billion deal with Cerebras for 750 megawatts of it. AWS is wiring these into its data centers too. Now here's the twist nobody saw coming. Intel went the exact opposite way. Their new chip, Crescent Island, throws out HBM entirely. Instead, it uses cheap laptop memory, LPDDR5X, the same kind of stuff in your phone. Why? Capacity. They cram up to 480 gigabytes onto one card. Air-cooled, 350 watts, built for agentic AI that needs to hold a huge context. But cheap memory is slow memory. You get a giant tank but a thin straw to drink through. Great for holding a model, painful for feeding one fast. And now you can see the whole battlefield. 3 bets, 3 beliefs. NVIDIA, balance compute and HBM, brute force it. Cerebras, kill the wall with on-chip SRAM, pay for it in capacity. Intel, forget top speed, give them a massive cheap tank of memory. And the thing they're all fighting over isn't flops anymore, it's bytes per second. The Inference era quietly stopped being a compute problem. It became a memory problem. So who's in trouble? Anyone selling raw compute as the headline number. If your chip can't feed its own cores, those flops are a lie on a spec sheet. The verdict. Wafer-scale is not a niche toy. For real-time inference, where speed per user is everything, it's the cleanest answer anyone has built. It won't replace every GPU, it doesn't need to. It just proved the wall was never permanent. And it forced the whole industry to admit the real fight was never about thinking faster, it was about feeding faster. Thank you.